Yes. Today's plan is to solve some MCQs. Most of them are NEST PYQs only. Okay. Based on mechanics. So mechanics will cover 2D motion, then laws of motion, gravitation, rotational motion, and simple harmonic motion, and also work energy principle and other stuff. Okay. So let us start with our first MCQ. This is from NEST 2023. A simple question based on the ideas of free body diagram. So let us read the question. This is actually a multiple select question, so more than one option may be correct. An accelerating train, acceleration a 1 meter per second squared of n blocks, have a mass distribution as shown in the figure. The rightmost block of mass nm is the engine. The blocks are connected through an aluminium cable of cross section 10 cm squared. The maximum allowed strain in the connecting cables is 0.001. Taking capital M as 1000 kilograms and Young's modulus of aluminium to be 7 into 10 raised to 10 Pascal, the correct choices are: all connecting cables will have equal strain. The difference of stress in any two consecutive cables is an arithmetic progression. The train can have at most 12 blocks. The maximum stress is between blocks having masses m and 2m. Now, one thing that we must note before we begin to solve this problem is the fact that cable always remains taut. Okay, cable always remains taut. This is important because they are saying that the train is all components of the train, all constituents of the train will have the same acceleration. Okay, that means if we consider the free body diagrams of individual objects or individual bogies, we can say, okay, all of them must be shown with moving with an acceleration equal to the acceleration of the train. Okay, have you understood that? Everything, the cables, the bogies and the engine, all of them are going to have the same acceleration. Okay, now using this and the ideas of free body diagram, we can answer the question very easily. So how to do it? Let us start with the smallest or the lightest of all. Okay, let us start with the bogie of mass m, and of course it is in balance vertically. Weight will be balanced by the normal reaction offered by the tracks. Okay, so let us only show its horizontal component. Okay, so this is being pulled in this direction by tension. Let us call it T1. Okay, so what will be T1 equal to? T1 will be equal to ma. Correct? Now let us consider this portion. Okay, let us consider this portion. Okay, so this is our system now. Okay, this is our body. What does it mean? It means this whole body, okay, this whole body is moving towards right with an acceleration a. So there must be a net force acting in that direction, and that force is actually the tension in this particular string, okay, or rope, cable. So let me show that tension as T2. Now please raise your hands. Can I say that T2 is equal to 3 ma? Can I say that? Of course, I have to say that because there is only one force and that's T2. Okay. Now, right here we realize that if T1 is ma and T2 is 3 ma, okay, I can say that T2 is 3 times T1, or essentially T2 is greater than T1. है ना? T2 T1 से ज़्यादा है. Now, if T2 is greater than T1, I must say, and the cross sectional area is same, so sigma 2 is greater than sigma 1. Okay, now when it comes to option D, they say maximum stress is between blocks having masses capital M and 2 capital M. But this stress between m and 2m is sigma 1, correct? But sigma 1 is now proved to be less than sigma 2, which is basically the tension in between 2m and 3m. So option D is ruled out. Please raise your hands if you understand that. Understood. Maximum stresses in between blocks having masses m and 2m. Now this conclusion also helps us in deciding the fate of option A, right? Because see, yes, stress.
Is B the wrong answer? Is B also wrong?
B, okay, we need to check that, but let's go to A first. Okay, assuming the elastic or proportionality limit and the validity of Hooke's law, okay, what do we know? Stress is directly proportional to strain. Stress is equal to Young's modulus into epsilon, correct? Now if sigma 1 is not equal to sigma 2, right, sigma 1 upon y will also not be equal to sigma 2 upon y, which means epsilon 1 will also not be equal to epsilon 2. Agreed? Now if epsilon 1 is not equal to epsilon 2, what can we say about option A? Tell me. Will they have equal strain or can they have equal strain? No. Yes. So option A is also ruled out. Okay. Now having gotten an idea of how the tensions are turning out, like T1 is MA, T2 is equal to 3 MA, we can actually make a list of tensions going from left to right. Okay, so let me again paste this figure here. Okay, let me paste that figure here for the sequence. Okay, look, now our eyes are on options B and C. Okay, well, at least one of them has to be correct because we have ruled out the other two. So let's go for B now. Okay, let's go for B. We have already computed T1 as MA, T2 as 3 MA. Okay, rather, okay, better let me write this 3 as 1 plus 2 MA. T3 will be how much now? 1 plus 2 plus 3 MA. T4 would be 1 plus 2 plus 3 plus 4 MA, isn't it? Now look here, they are saying the difference of stress, but the difference of stress is as good as difference of tensions, because when we divide that by the area of cross section we will get the stress, isn't it? So it is enough to deal with the tensions. Okay, now how much will T2 minus T1 be? Tell me, how much will T2 minus T1 be? Will that not be equal to 2 times MA? Correct. How much will T3 minus T2 be? T3 minus T2, will that not be equal to 3 MA? Correct. What will be T4 minus T3? Will that not be equal to 4 MA? It will be equal to 4. So as you see, as you progress towards the engine, okay, okay, T n minus 1, what would it be? T n minus 1, that will be the maximum tension, okay, and that will be the sum of first n minus 1 natural numbers, isn't it? And that will be that natural number into the next natural number upon 2 standard formula into n. But now do you agree that the difference in the tensions will actually be in arithmetic progression? 2 MA, 3 MA, 4 MA, 5 MA and so on. Please raise your hands if you understand that. Tensions themselves are not in AP. Let me note that here. TJs are not in AP. But Tj minus Tj minus 1 are. Is it clear? Please raise your hands if you understand this option, like why B is correct. B is correct because of this. Okay, B is correct because of this, the difference. So B is correct. ठीक है, B is correct. What about C? The train can have at most 12 blocks. Now, for deciding whether C is right or wrong, we must use another fact here, and that fact is the maximum allowed strain in the connecting cables is 0.00. Now, please pay attention. For maximum allowed strain, we must consider the maximum stress, isn't it? And what is the maximum stress? Say sigma max is equal to Tn minus 1 upon area. Okay, this is sigma max. And what is epsilon max? Epsilon max, maximum strain, is equal to sigma max upon area. Oh, sorry, not area, Young's modulus. Young's modulus. Correct. Now you want the value of sigma max upon y to be less than which value? 0.00. Okay, now let me also paste this problem again so that we no longer be required to scroll every time. Okay, fine. Okay, so sigma max upon y should be what? Less than 0.001 or equal to. Okay, which part of the problem have we made use of in obtaining this particular inequality? This part. Is it clear? Yes, no? Clear, right? Okay, okay, yes. So let's go to sigma max now. Okay, let us go to sigma max now, which is Tn minus 1 upon A. So n into n minus 1 ma by 2. Okay, this is only T. Okay, this is only T. We must divide this by A. A दिया है क्या? Area है 10 raised to 10 centimeter square. So 10 into 10 raised to minus 4 into 1 upon Young's modulus. What is Young's modulus? 7 into 10 raised to 10. ठीक है, 7 into 10 raised to 10 should be less than or equal to 0.00. Okay, now better if we substitute the values of m and a also. M is 1000 and small a is acceleration, which is 1. Alright, so we now get n into n minus 1 less than or equal to now let's start dealing with the powers. Okay, 7 into 2, so that's 14. Now let's go to powers of 10. First let us cover this, so that's minus 3. Okay, minus 3. Now we go to the 3 powers in the denominator, so plus 1, minus 4, plus 10, and then the power in the numerator, so minus 3. Okay, now look, minus 3, minus 4, minus 3, they will actually cancel the effect of 10, right? So it will basically be less than or equal to 140. So basically now you are in search of that natural number n which when multiplied by its previous natural number, the product should be less than 40. Okay, now we know that 11 into 10 is 120. Okay, so we'll go for 12 into 11. Okay, 12 into 11, how much is that? 132. Okay, and how much is 13 into 12? 156. Okay, 156, which means if we choose n as 12, then the tensions or the strains are well within the permissible limits, because the maximum strain will be less than 0.001. So we can say 12 into 12 minus 1 less than or equal to 140. So the correct answer is 12. So does that meet the requirement in C? Yes. So B and C are right, E and D are not right. Have you followed this?
Yep.
Right?
Yes.
Now look how cleverly they have made use of concepts from other topics also. Like usually in free body diagrams, we just draw the forces, show the forces, and apply second law of motion. But in this case, they also brought arithmetic progression idea from mathematics. Mechanical properties of solids, they are also there. Young's modulus, although I mean, it's easy, but we need to think in that particular direction. All right. Okay, fine. AP formula was there, also this formula which is common in maths, sum of first and natural numbers. Shravani, if you are not going to attempt maths, at least make sure that you learn some formulae from mathematics, okay, especially binomial theorem, derivative integrals, some trigonometry and vectors and these sequences and series. Okay?
Sure, sure.
Yeah, okay. So that's question 1 for you. Now let's go to another problem from next 23. This is from second shift, question 2. Okay. A heavy disk of radius r and mass m is placed horizontally. Heavy disk, radius r, mass m, placed horizontally. A small coin of mass m, see now this small means we can ignore the size of the coin. Okay, radius of coin, negligible. Okay, so you can treat it as a point. Is placed at a radial distance r by 2 from the center. Okay, r by 2 from the center. The disk is now, that means t equal to 0, given a constant angular acceleration of magnitude alpha radians per second squared about a vertical axis passing through its center. Okay, about a vertical axis passing through its center. If mu s and mu d are the coefficients of static and dynamic friction, respectively, between the coin and the rotating disk, then option A, at t greater than 0, the force due to static friction acts radially inwards. At t greater than 0, the magnitude of the force due to static friction is always mu s mg. The coin starts sliding at time 1 upon alpha root 2 mu s g by r, and the coin reaches the edge of the disk at time t equal to 2 by alpha root of mu d minus mu s g upon r. Okay, so in this problem, of course, we must deal with uniform circular motion. Okay, not uniform, it is circular motion, and friction, and the concepts of centripetal and centrifugal forces. Okay, so let us start. So here is our disk. Now let us consider the top view of the disk. Okay, let us consider the top view of the disk. Okay, and then let's say this is our coin. Okay, it's our coin, and if this is the distance r, okay, if this is the distance r, this is r by 2. Okay, this is r, and the disk is set in motion. So let's say this, and angular acceleration is constant. Okay, so I can say omega I equal to 0. Okay, omega I is equal to, because they are saying the disk is now given a constant angular acceleration, and they are saying it's placed horizontally. Placed means its initial angular velocity is 0. So because the angular acceleration is constant, we can apply v equal to u plus at for circular motion. Okay, which means omega f is equal to omega I plus alpha t. Okay, which means you can just call it omega now, alpha t. Okay, omega equals alpha t. Now if we look at the coin, okay, if we just look at the coin and its free body diagram, okay, free body diagram. Now let's say front view of the coin, or let's say we can draw it right here, because the disc is heavy enough to balance the weight, okay, to balance the weight of the coin. So the only force that this particular coin experiences, which is causing it to accelerate to change its direction, is the frictional force. Okay, it is frictional force. So do you think that option A is correct? At t positive, the force due to static friction acts radially inwards? Yes. Okay, after disk begins to accelerate, after disk begins its motion, okay, after disk begins its motion, coin performs circular motion. Okay, coin performs circular motion. Okay, now tell me, if the coin is performing circular motion, how many components will it have? Yes, how many components will it have? It will.
Centripetal acceleration
Okay.
and
Yes.
tangential
Yes. ये कॉइन परफॉर्म सर्कुलर मोशन, सो सेंट्रीपेटल तो होगा ही. Okay, now will it have tangential acceleration? Please tell me. Centripetal is there and tangential is there. Okay, please tell me what will be the centripetal acceleration's value. Please tell me what will be the centripetal acceleration's value or expression. Is it not r omega squared? Yes. Is it not
Yes.
r omega? Yes. Okay. It's r omega squared. So what can be said about its variability? R by 2 alpha squared t squared. Okay. And what will be the tangential acceleration? Will it not be equal to r by 2 alpha? Yes or no?
Yes, sir.
Now let us revisit option A again. At t greater than 0, the force due to static friction acts radially inwards. Now, do you think option A is correct? Having realized that the coin is going to have two accelerations, one is the centripetal acceleration. Okay, centripetal acceleration. Okay, let's call it AC, and it will also have a tangential acceleration. Okay, and they're saying at t positive, that means alpha is still there. Okay, AC and AT, and the resultant of them will be in this direction. Okay, the resultant will be in that direction. Now, most important part, which force or which forces are acting in the plane of the motion on the coin? Please tell me. In
Frictional force.
एक ही फोर्स है ना, फ्रिक्शनल फोर्स, और कोई फोर्स है क्या?
Yes, sir. Frictional force.
नहीं,
No, sir.
no other force. Okay, now say because no other force acts on the coin in the plane of motion. Okay, in the plane of motion, theta is not equal to 0. Therefore, friction won't point. Okay, friction won't point along center or towards center. Have you understood this?
Yes, sir.
Others, do you have any queries here? Like, why is the. See, had the disk been rotating with uniform speed, then definitely the friction would be pointing towards the center. Okay? And that's what we thought initially. But what did we realize then? We realized that friction will definitely have a component directed towards the center. Okay, because it has circular motion, so centripetal acceleration to rahega hi. But here tangential acceleration is also there, right? Tangential acceleration is also there, and that's given by friction again. So friction will not point towards the center, so option A is not correct.
So where will friction point in this case? Will it point opposite to A net?
No, friction is actually supporting the coin to stay in its to keep its motion with the disc, so it will point in this direction only.
Okay.
Got it? Yeah. Okay. So option A is not right. Now let's go to B. Okay, let's go to B. Now please tell me, will the magnitude of frictional force be always mu s mg?
No, sir. It's the maximum frictional.
Yes. Yes. Correct. This is limiting force of static friction. Okay, depending on omega value, okay, depending on omega value, the friction adjusts its value. So when the motion starts, the frictional force's magnitude is smaller than the limiting. Okay, so depending on the omega value, the friction will adjust, so B is not right. Okay. Okay. Now tell me, what do you think about options C and D? What do you think of options C and D? Let's go to option C
Sir,
now.
the,
Huh.
sir,
Huh.
the coin starts sliding when the net force on the coin becomes equal to the limiting value of the friction. From there we can find T.
Correct. Correct. The coin starts sliding at time t, which is 1 upon. So we need to basically find the time t. Okay. When will that happen? Friction reaches limiting value. Okay. Now, what is the limiting value of friction? Mu s mg, right? The limiting value of the friction is mu s mg. Okay. Now, at this time, okay, let it be t. We need to find it. What will be the angular speed at t? Omega will be alpha t. Okay, omega will be alpha t. So in this direction, okay, in this direction, the centripetal acceleration will be there, and the centripetal acceleration will be equal to r by 2 alpha squared t squared. Okay, and this will be the tangential acceleration, which will be r by 2 alpha, you know, omega alpha t. Okay, now look here, is it possible to determine the component? Okay, we actually need to consider the centrifugal force in this case, because from the frame of reference of coin, okay, it is being thrown towards right, okay, or right in the sense away from the center. Okay, so which part of the which component of the frictional force should we consider? We should consider the frictional force in the direction of the centripetal force. That means we must consider this force in this component. है ना? Are you getting this? Yes.
Yes, sir.
Okay. Okay. So now the question is, how are we going to find that angle? Because one of the components is okay. Say this angle is theta. So cos theta would be r by 2 alpha squared t squared upon r by 2.
Sir, tan theta.
नहीं, हमें तो cos theta लगेगा ना. See, friction is acting in this direction, correct? We want its horizontal component, है ना? We want its horizontal component. So how will we find that? R by 2 root of alpha raised to 4 t raised to 4 plus alpha squared. Okay. Now the coin will start sliding when m r by 2 alpha squared t squared, okay, is greater than or equal to mu s mg. r by 2 कैंसिल हो जाएगा, है ना, यहाँ पे. And we must consider cos theta now, which is alpha squared t squared upon root of alpha raised to 4 t raised to 4 plus alpha squared. Is it clear? The cosine component of the frictional force, okay, when it fails to meet the requirement of balancing the centripetal force, the coin will begin to slide. Is that clear?
Yes, sir.
Okay. So m will go, alpha squared t squared will go. Okay. So let's bring the root term here. Mu s will stay there. Okay, 2 will go in the numerator, g will be there, and r will sit in the denominator. We can definitely take alpha common. Okay, so let's first square that. Bring alpha squared there. Okay, and then divide by alpha raised to 4. Okay, then divide by alpha raised to 4 and then take its fourth root. So it would be 1 upon alpha into bracket 4 mu s squared g squared by r squared minus alpha squared. Okay, now that is all not actually matching with the option given in the official key. In the official key, this option is given to be correct, and also option A, which we did not get correctly, and then we have concluded that option A is not right. Look here, had we considered the direction of the frictional force, okay, had we considered the direction of the frictional force towards the center, मतलब अगर हमने ऐसे सोचा रहता कि फ्रिक्शनल फोर्स जो है उसको ये वाला कंपोनेंट है ही नहीं, एक्चुअली है, वाकई में उसका कंपोनेंट है वहाँ पे, है ना? अंडरस्टूड? फ्रिक्शनल फोर्स इज देयर इन दिस डायरेक्शन ऑल्सो, बिकॉज अदरवाइज इट वुड नॉट एक्सेप्ट, विल वो वहीं पे ये होगा, ठीक है? तो अगर हमने वैसे लिया तो ये कंपोनेंट नहीं आएगा उसमें, and then it would match with the things that they have given. But now we need to argue why can that possibly be right or incorrect. Okay, let's think about it. Because otherwise none of the options will become right, correct? C भी नहीं होगा. Coin starts sliding at time t equal to 1 upon alpha 2 mu s g pi. See if we are missing something. After coin begins its motion, coin performs circular motion. Therefore centripetal acceleration क्योंकि circular है, tangential क्यों आएगा? क्योंकि डिस्क एक्सेलरेट हो रहा है. ओके
Sir,
हाँ,
uh, centripetal force will be balanced by centrifugal force. So I think
नहीं 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 नहीं
uh,
नहीं 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 वो नहीं है, नॉट दैट. सेंट्रीपेटल
no.
कभी भी सेंट्रीफ्यूगल को बैलेंस नहीं करता भाई, उनका सिर्फ मैग्नीट्यूड सेम होता है और डायरेक्शन अलग होता है. नो नो नो, सी आवर मेन कंसर्न इज the direction of the frictional force. We have concluded that because the coin has a net axis, because it is not uniform circular motion. यूनिफॉर्म सर्कुलर मोशन में ये ज़ीरो होता है ना? तो नेट एक्सेलरेशन जो भी है उसका वो सेंट्रीपेटली होगा. यहाँ पे हमारा जो कॉइन है वो उसका एंगुलर स्पीड बढ़ रहा है, तो उसको टेंजेंशियल एक्सेलरेशन वाला कंपोनेंट भी होगा. करेक्ट? हैव यू रियलाइज दैट? बिकॉज आवर कॉइन is not only performing circular motion, but it is performing circular motion with increasing angular speeds. It must have a tangential component of acceleration. Is that clear?
Yes, sir.
Okay. Now, okay, frictional force का direction अभी भी मतलब जो ऑफिशियल आंसर किए उनमें उन्होंने बोला कि ए सही है और सी सही है. मतलब इन ऑफिशियल आंसर की दे से ए इज करेक्ट एंड सी इज करेक्ट. सो वी हैव टू नाउ सी our arguments about frictional force, because I don't see any issues with these arguments. ये तो सही है, सेंट्रीपेटल तो रहेगा, टेंजेंशियल भी रहेगा. सेंट्रीपेटल एक्सप्रेशन इज ऑलवेज दैट आर ओमेगा स्क्वायर, टेंजेंशियल एक्सप्रेशन इज दैट आर अल्फा. तो आर बाई 2 है वो, क्योंकि कॉइन अभी भी सर्कमफरेंस पे नहीं है, हाफ में है. सिंस नो अदर फोर्स एक्ट्स ऑन द कॉइन इन द प्लेन ऑफ द मोशन, फ्रिक्शन वोंट पॉइंट टुवर्ड्स द सेंटर. या ऑलवेज वो तो नहीं है, दैट्स ऑल क्लियर. Friction reaches limiting value. Okay, do one thing. We'll keep this problem aside. Let me take a
Sir,
deeper.
I answer.
हाँ बोलो.
This option C is correct, I think, because this centripetal basically we have two component of friction. So one component is along the center. So I have equated centripetal acceleration.
नहीं
equals,
नहीं नहीं नहीं, देखो
F.
देखो वो आंसर आए.
Equate means greater than.
See, the point is not equating r by 2 alpha square t square equal to mu s mg. ये पॉइंट नहीं है, ये किया तो वो आएगा ही उसका उनका आंसर, है ना? पॉइंट मेरा वो नहीं है. मेरा पॉइंट ये है कि फ्रिक्शनल फोर्स की जो डायरेक्शन है वो अगर टुवर्ड सेंटर नहीं है तो उसका एक कंपोनेंट लेना पड़ेगा ना हमें उस डायरेक्शन में. Got it?
Yes.
Because our coin is not performing constant angular velocity motion, उसका acceleration constant है. Got it? Because its acceleration is constant, it must have a force which will provide it with the with the tangential acceleration. वो मेरा point है. ये equate किया तो आ गया, लेकिन इसमें हम क्या assume कर रहे हैं? फिर we are assuming that friction is along radius. But if friction is along the radius, then which force is taking care of the tangential acceleration? Can anybody tell me that? If friction is along the radius, if the disk is rotating like this, okay, and let's say this is the coin, and it is also possessing angular acceleration as well as angular speed, coin has two accelerations then, the tangential and centripetal. तो मेरा सवाल ये है कि tangential को फिर कौन सा component balance कर रहा है? Is that clear what I'm asking? The net acceleration of the force, net acceleration of the coin is in this direction. है ना? R bar 2 alpha otherwise we need to consider two independent motions of the coin. Okay, we need to consider two independent motions of the coin, one in the radial direction and one in the tangential direction. But again, if we consider the individual forces there, I equal to mu mg, individual forces equal to mu mg, the frictional forces magnitude will actually increase, because you will be considering the limiting force in this direction as mu s mg, and in this direction, okay, because it is keeping with the disk, it would be, well, less than or equal to mu s mg. तब वैसे किया तो वो mu s mg ही आएगा उसका balance. लेकिन what they have said in option A is that the force due to static friction acts radially inwards. Now what I don't understand here is if it is force due to static friction, we must consider both the forces, as in the force that is keeping it in the circular motion, and the second, the force that is actually helping the coin accelerate with the disk. ठीक है? Cool. Okay, we'll keep this aside and take a deeper look at it, but considering what we have, considering the 4 points that we have made here, I think frictional force cannot be directed radially inwards, क्योंकि उसका एक component तो रहेगा ना tangential में. No other force is there. ठीक है? Fine. Okay, let's move on. Third question. This is from NEST 2022 second shift, a concept based problem based on center of mass. ठीक है? A person is dropping identical tennis balls from rest at a rest of 1 ball per second. When the 6th ball is about to be dropped, the first ball has just reached the ground. At this instant, the center of mass of all 6 balls is in between the second and the third ball from the ground. The difference between the velocities of any two consecutive balls is always constant. The separations between 3 successive balls from the ground in the 4th second are in the ratio 5:3. The distance between 2 consecutive balls increases linearly every second. This is also a multiple select question, so we have to deal with each and every option separately. Okay. First of all, let us try to consider the figure. Okay, let's try to consider the figure. Let's say this is the point of release the height of release, and let us suppose this is the ground. Okay, now look here. Let us say at t equal to 0, ball 1 was released, t equal to 1 second, ball 2, t equal to 2 seconds, ball 3, t equal to 3, ball 4, t equal to 4, ball 5, and t equal to 5, ball 6. ये important है. क्यों important है? They are saying when the sixth ball is about to be dropped. Now if sixth ball is about to be dropped, it means how much time does the first ball have to reach the ground? 5 seconds. Please raise your hands if you understand that. गलती से अगर 6 ले लिया तो चेंज हो जाएगा सिचुएशन. ओके, they are saying when the sixth ball is about to be dropped, the first ball just reaches the ground. Okay, so how much time does the first ball have? First ball has 5 seconds. So second has 4, third has 3, fourth has 2, and fifth has 1 second. ठीक है? Okay. Now can we find the center of mass? Okay, and can we find its position? Yes, we can. First of all, let us consider the position of this ball. Okay, that's B6, and this is going to be the position of P1. Okay, this is going to be the position of P1. Now look here, all these balls are being dropped. That means all of the balls, the initial velocity is 0. Okay, now if we are to calculate the distances traveled by these balls, we can use the equation s equal to ut plus half at squared. Correct? And because u is equal to 0, s will be equal to g by 2t squared. Correct? Let's take g as a 10 for our simplifications. Okay, so s will be equal to 5t squared. Correct? S will be equal to 5t squared. What does it mean? It means what will be the distances of these balls from the top? Okay, what will be the distances of these balls from the top? Okay, what will be the distances of these balls from the top? And can we also find out their speeds using v equal to u plus at, and because u is equal to 0, we can also say v is equal to 10t. है ना, v is equal to 10t. Now this can also help us in getting some of the options. Okay, and also this one. So these are the expressions. अब देखो, okay, let's also get this. Okay, so what will be the position of b5? Okay, what will be this distance? Can anyone tell me that? That would be 5, right? b4, how much will this distance be? 20. Okay, 20. p3 का कितना होगा?
45.
45. b2 का कितना होगा?
20.
20 कैसे रे?
1690. 1650.
नहीं 80. हाँ 80 होगा. And the height of release would be
125.
125. Correct. Now look here, let us find it out from the top also, because the center of mass is the same point, right, relative to the system. Okay, so how can we find the center of mass? What's the definition? We need to find the y coordinate now, and let's consider this as positive. Okay, let's consider this as positive. So what is the definition? Summation mi yi, okay, summation mi yi upon summation mi. I know. Okay, now the masses are constants, isn't it? Identical balls बोला है उन्होंने, तो हर एक बॉल का मास सेम हो जाएगा. ठीक है, so m into bracket. Now what values do we need to consider? 125 plus 80 plus 45 plus 20 plus 5 plus 0, and we must divide this by 6m because there are 6 balls. Is that clear? 125, 80, 45, 20 and 5. Please raise your hands if you understand that. Okay, mm को कैंसिल करेंगे. 125 plus 80 plus 45 plus 25. ठीक है, 180 125 plus 80 plus 45 plus 25 upon 6. That's 45.83. Okay, that's 45.83 from the top. मतलब 45 यहाँ पे हो गया, 45.83 तो यहाँ पे सेंटर ऑफ मास होगा. Okay, now will that be between B2 and B3? Yes, option is correct.
Yes.
ठीक है, center of mass is in between second and third ball, so option is correct. The difference between the velocities of any two consecutive balls is always constant. Let's see. The difference between the velocities of any two consecutive balls is always constant. Acha. See, now this particular equation, v equal to 10t, will come to our rescue. Okay, v is equal to 10t. Okay, now because these balls are being released, after a gap of 1 second, okay, whatever speed the, let's say, vn attains, vn plus 1 will be equal to 10 into t minus 1. Please raise your hands, because the n plus 1th ball has 1 second lesser to travel in space. Why? Because it has been released 1 second after the previous ball has been released. Is that clear? So if you take the difference, between these two, it is actually g, right? It's actually g, 10t minus 10t, so this time. Is it constant? It is constant. Okay, it is independent of time. So can option B be considered correct? Yes. Please. Any doubt here?
No, sir.
Okay, A correct, B correct. Achha, let's go to C now. The separations between 3 successive balls from the ground in the 4 seconds, are in the ratio 5:3. Okay. अब इसका कैसे करेंगे? फोर्थ सेकेंड ही बोला है उन्होंने, है ना? फोर्थ सेकेंड मतलब हमारे जो बॉल्स है वो क्या रहेंगे? 0 पे B1 आया, 1 पे B2 आया, 2 पे B3 आया, 3 पे B4 आया, 4 पे B5 आया. The separations between 3 successive balls from the ground in the 4th second are in the ratio 5:3. Okay, 4th second बोला है तो 1 2 3 4. Okay, so we can consider B2 now. Okay, B2, B3 and B4. Okay, see now what they have said is separations from the ground. Okay, separations from the ground. So B2 का कितना रहेगा? Wait, 4th second है ना?
125 minus 80.
नहीं, वो मुझे याद पता है. I'm just checking if we have missed any second. Okay, 4th second में कितने बॉल आए? 5 बॉल आए ना? तो B2 अभी तक ग्राउंड पे पहुंचा नहीं है. करेक्ट. ओके, तो 125 minus 80. B3 is 125 minus 45. B4 125 minus 20. Okay. अभी इनका इनका सेपरेशन निकालना है. Sorry, not 125 minus 80. My bad. 80 minus 45. Oh wait. हाँ, separation. The separations between successive balls from the ground in the, it doesn't matter because we only want the separations, right? So 80 minus 45 is 35, and here we must consider 45 minus 20, so 50 or 20. Now if we take the ratio 35 is to 25, 7 by 5 आ रहा है वो, so C is not right. Okay, C is not right. See, what they had asked, the separation between three successive balls. Okay, the separation between successive balls, so we considered them as B2, B3, B4 in the 4th second, right? In the 4th second, because the ball, the B1 has, we can also say that it's B1, B2, B3 because the motions are identical. Okay, motions are identical. ठीक है, ये समझ में आ गया या नहीं आया? Understood? Okay. Fine. So C नहीं है सही. The distance between any two consecutive balls increases linearly every second. Now let's explore this now. Is it correct or is it incorrect? Option D. Okay. Now what is the formula for the distance traveled? Okay, what is the formula for distance traveled? Have we written it here?
Sn minus 1 sir.
नहीं, पहले formula तो देखो. S is 5t squared है ना?
5t square.
हाँ, S है 5t squared. तो इसका जो पहला, इसके आगे जो बॉल आएगा उसका क्या होगा? लेट्स से ये S1 बोला है, करेक्ट, 30. टेक द डिफरेंस और लेट्स से S1 minus S2 जैसे, तो दैट वुड बी 10t plus 25 है ना? 10t plus 25. Is it increasing linearly every second? Yes, because it's a linear function. हाँ, क्या हुआ?
10t minus 5.
हाँ, 10t minus 25 minus 5. सब्ट्रैक्ट कर रहे हैं ना, सही. ठीक है. But is it increasing linearly every second? Yes, because the slope is positive. Okay, so it's linear.
5 minus
क्या हुआ?
minus के बाद 5.
अरे हाँ, सॉरी, 5 का स्क्वायर कर दिया तो फिर minus 2t. Yeah, okay, that's right. Yes, so option D is correct. ठीक है? Cool. Any doubt in this question?
No sir.
Okay. Now let's consider another mixed concepts question. Okay, this is our 4th question. So after solving this one, I will show you a similar question from one of the previous JEE advanced question papers, which makes use of a similar concept or approach which we will take for this one. Okay? In this problem, we will make use of the ideas of from rotational motion and also the ideas from kinetic theory of gases. Okay? A horizontal cylinder closed at one end is rotated with constant angular velocity omega. Okay, it is rotated with a constant angular velocity omega about a vertical axis passing through the open end of the cylinder as shown in the figure. So this is the closed end and this is open. It is moving with constant angular velocity, so here we don't have angular acceleration, omega is constant. Okay, about a vertical axis passing through the open end of the cylinder as shown in the figure. The outside air pressure is P naught. Outside air pressure is P naught, temperature is T, and the molar mass of the air is mu. Okay, molar mass of the air is mu. Assume the air to be an ideal gas. बोला है ideal gas equation use करो. And the temperature T remaining constant, isothermal है. Everywhere. The air pressure inside the cylinder is best described by P is equal to P naught 1 plus ln 1 plus omega squared 1 plus mu omega squared x squared upon 2 RT, option A. P equal to P naught into bracket 1 plus mu omega squared by 2 RT, option B. P is equal to P naught 1 plus e to the power minus 2 RT upon mu omega squared x squared, option C. P equal to P naught e raised to mu omega squared x squared upon 2RT. Okay, so how to describe the pressure? Look, by giving this x here, and the pressure at that particular vertical level at P, they are telling us something. Okay, what we can consider is, we can consider a thin disk of thickness dx. Okay, we can consider a thin disk of thickness dx, that we show it here. Now this is the side view, and let's say this is the axis of rotation. Let's say this is the axis of rotation, and this distance is x. This distance is x. Okay, this distance is x, and then this is going to be the distance dx. Okay, this is going to be the distance dx. Acha. Now, the forces that are acting on this particular disk, okay, to keep it in that constant uniform or constant circular motion, okay, the forces acting are pressure P here, pressure P plus dP here, okay, because there will be a slight change in the pressure, right? And that's why we are calculating all these things. If the pressure had been constant throughout, then there is no need of considering P plus dP at all, just P. Okay? But according to second law, this must be equated with what? M r omega squared. अभी r cylinder का मत लेना, cylinder का r की ज़रूरत नहीं है अभी. Which r are we looking for? The distance of that particular object exactly from the axis of rotation. So this will be mx omega squared. Now please raise your hands if you understand this. Has everyone understood that? Okay, okay. So having figured out the main approach, or the way we should approach, now we can start looking after the simplification. Okay? So second law. Yeah, okay, also we haven't multiplied this by area, because that's pressure. We cannot balance force with the pressure, so we must consider this. Okay? So second law of motion tells us mx omega squared must be equal to P plus dP into A minus PA. So that basically gives us what? AdP. AdP. Okay. mx omega squared equals AdP. Now please raise your hands if you understand this part. mx omega squared equal to AdP. अच्छा, अभी हम लोगों को करना चाहिए. Okay, what should we do? We must first consider the mass of the disk. Okay, mass of the disk. Mass. Can we say that the mass of this disk is the volume of the disk into density? Well enough. Let's consider it as dV now because it's a small volume. Okay, or even if we consider it as V here. Okay, even if we consider V here, we can say that it is rho AdX. क्लियर? मतलब अभी इस इक्वेशन में क्या चेंज हो गया? m के बदले आएगा रो ए डी एक्स. ओके, रो ए डी एक्स एक्स ओमेगा स्क्वायर है ना. रो ए डी एक्स इज मास, एक्स ओमेगा स्क्वायर इक्वल टू ए डी. सो द डिपेंडेंस ऑन एरिया इज गॉन नाउ. ओके, डिपेंडेंस ऑन एरिया इज गॉन नाउ, एटलीस्ट एज ऑफ नाउ, and we are left with omega squared rho x dx is equal to d. Now one thing I would like to tell you before we proceed is this: if you integrate this, okay, okay, you will see the expression in the option. So x squared by 2 into something is equal to p plus, let's say, p naught, constant of integration. Now the thing about this is it's there in the options. Okay, if you look at option B, it's there. मतलब सिर्फ x squared by 2, e raised to b नहीं, log भी नहीं. Okay, यहाँ पे e raised to है, यहाँ पे log है. But if you go to option B, there it just has x squared by 2. But that is not right. Okay, this option is not right because, why is that not right? Because density is not constant. Along x, because of the centrifugal action, the air here will be denser than the air here. Please raise your hands if you understand that. Due to centrifugal action, the molecules of the air will be pulled, or rather pushed, towards the closed end of the disk. ठीक है, तो अभी हमें rho को x के फंक्शन के फॉर्म में एक्सप्रेस करना है. That's our objective. Okay, so how to express density? In terms of the
Sir, we
position.
will use isothermal condition. P1 V1 equals P2 V2.
नहीं. Okay, see, look. First of all, we have to consider the ideal gas equation. Say PV is equal to nRT. Okay, say PV is equal to nRT. ठीक है. Now what we can do is we have to get the expression for density, right? We have to get the expression for density. So let us differentiate both sides of this equation with respect to V. Okay, say P is equal to RT dN upon D, because R is constant, T is constant. Okay, and number of moles, okay, it's not constant because density is not there, and V. ठीक है. Now look here. In this particular disk, okay, suppose we wish to calculate the total mass of air molecules there. Okay, total mass of air molecules there. We are given molar mass. We are given the molar mass, which means in order to calculate how much mass is there of air in that particular disk, we must multiply this molar mass by the number of moles. इज दैट क्लियर? हमको मास चाहिए क्योंकि हमको डेंसिटी चाहिए, डेंसिटी मास अपॉन वॉल्यूम है, तो मास को कैसे निकाल सकते हैं? मोलर मास को
Yes, sir.
नंबर ऑफ मोल से मल्टीप्लाई करके निकाल सकते हैं, ठीक है? मास ऑफ द एयर इन द डिस्क इनटू नंबर ऑफ मोल्स. So pay attention. What can be said about density now? It is mass upon volume. See, that's the reason I was initially telling you to take not take V but take dV here. Okay, to take dV here. Okay, because well, you could have taken it as V, no issues. But on one side you are saying rho V and on the other side you are saying dx. So it's appropriate or better if you use this dV. ठीक है? तो अभी हम लोगों को क्या करना है? डेंसिटी हमको निकालना है, रो ऑफ एक्स. तो डेंसिटी को निकालने के लिए मास को वॉल्यूम से डिवाइड करो, ठीक है? नाउ लुक, that dn by dv is there, dn by dv is there, okay? That dn by dv can be written as p by rt. Okay, dn by dv को हम p by rt लिख सकते हैं. Please try to understand carefully the way we are carrying this forward. We know p is already a variable pressure, okay? And we now know that p is directly proportional to the rate at which number of moles changes with volume, okay? dn by dv, because r and t are constants. T is constant because it is given that the process is isothermal. है ना? Now we have got the successful expression for rho of x, okay? Rho of x. So let's see. Therefore, omega squared rho x, although we didn't get it as a function of x, we have got it as a function of p now, ठीक है? Mu squared, sorry, omega squared rho है हमारा p by rt, okay? Rho is our p by rt. Let me use green color for highlighting that. Rho, उसको अभी हम लिख रहे हैं mu into p by rt. Sorry, I missed mu part. Mu into p by rt, है ना? ओमेगा स्क्वायर हो गया. Mu p by rt is our density, okay? Into x dx equals t. Okay, and now we can integrate this, keeping in mind that we must send p on this side. Omega squared is a constant now, guaranteed. Rt is also constant. Mu is constant. Integrate x. This, okay. So mu omega squared by rt x squared by 2 is equal to ln p plus c. Okay, now look here. Let's say x is equal to 0, p is equal to p naught, क्योंकि यहाँ पे तो एटमॉस्फेरिक प्रेशर ही है ना. Here the pressure is atmospheric, it's given p naught. So when x is 0, p is p naught. When x is 0, p is p naught. Therefore mu omega squared upon rt into 0 is equal to ln p plus c, which implies that c must be negative ln p naught. Got it? So at the end, eventually what we will get? Mu omega squared x squared upon 2rt is equal to ln p by p naught. Okay, so what will be p by p naught then? P by p naught will be e raised to mu omega squared x squared upon 2rt. Therefore p will be equal to p naught e raised to mu omega squared x squared upon rt. ठीक है? We have that in the options. Option D. Is it clear? If you haven't understood it yet, let's go through the solution again. Okay, slightly difficult problem. First step is that we have to figure out that the question is meant to be solved using integration. Okay, the question is meant to be solved using integration. Okay, so we considered a disk, okay, a disk of thickness dx at a distance x from the axis of rotation. Then we considered its free body diagram, although we haven't yet shown the weight, but we know weight will be balanced anyway. So we only considered its horizontal forces acting on it, two of them, P into A from the right hand, P plus dP into A from the left hand, applied second law of motion, to get an equation of this kind. So the mechanics part is over now. Okay, the mechanics part is over. Now we enter kinetic theory of gases. Okay, now we enter the kinetic theory of gases, and what do we realize is that because density is not constant along x, we cannot consider it as a constant. Okay, so we either need to express density as a function of x or as a function of p. Both are variables. We successfully managed to express density as a function of p and not x, but that doesn't matter. Okay, initially we thought we could express it as a function of x, but it turned out using ideal gas equation that density can be better expressed in terms of pressure. So we did that. Density, we did that. Okay. So once we did that, we went back to the expression which we had obtained from second law of motion, that means this expression. Okay, this expression. We continued our integration, and that integration was itself very simple. Integral of x is x squared by 2, integral of 1 upon x is log x. We did that, and at the end we substituted the boundary condition that when x is 0, the pressure is P naught, this one. And by doing this, we arrived at the conclusion that the pressure is equal to P naught e raised to mu omega squared x squared upon RT. So the maximum pressure as expected is to the left boundary where x is maximum. ये समझा गया?
Yes, sir.
Yes, sir.
It's slightly difficult because kinetic theory of gases has been mixed with rotational. Okay, now I want to discuss another problem, and then maybe we'll stop. So this problem is from JEE Advanced, and the question is very similar to this, where rotational motion has been combined with mechanical properties of fluids or fluid mechanics. A U-shaped tube contains a liquid of density rho, and it is rotated about a line as shown in the figure, the red line there. Find the difference in the heights of the liquid column. Assume diameter of the tube d to be very much less than l. First of all, we must realize why is this pressure greater here. That's because due to centrifugal action, the liquid will be pushed in this way, and then it will rise, and this rise will continue as long as the pressures don't balance or the force. Okay, so the approach is just similar to what we considered here. Okay, here we had considered the disk. Okay, here we had considered the disk like this one. Let me draw the figure here for you, and then I think you can continue. Okay, so let's consider a disk like a disk here. अभी हम लोगों को डिस्क नहीं कंसिडर की तो भी चलेगा, क्योंकि अच्छा उन्होंने बोला है डायमीटर रेडियस ऑफ द ट्यूब तो देना पड़ेगा. ठीक है, so let's consider that. Okay, let's consider that. Let this be our point of integration. So let this be x, है ना, let this be x, let this be dx. Okay, let this be dx. Then what? Okay, so we need to show the forces here. P here, P plus dP from this direction. Don't forget to multiply it by area, क्योंकि ये सिर्फ प्रेशर नहीं है, फोर्स लेना पड़ेगा हमें बैलेंस के लिए. ठीक है. Now and where will be the centripetal force be acting? Okay, centripetal force will be acting in this direction. Again the same way we calculated for the mx omega squared. Similar expression we will get, mx omega squared equal to dpa or adp, and now you have to continue after from this. Okay, see here density is constant. Okay, so here density is constant, so what you have to do is m can be taken as a volume into density. So volume is ADX, where A is the cross sectional area, into density, x omega squared is equal to AdP. A gets cancelled, and then you can basically find out the pressure by integrating, or the rise in the pressure. Okay? So I am leaving this to you. I included it because same concept is there in both these problems. Okay? Okay. So I'll stop here, but there are some other problems which I've kept in the sheet. Please try them. There are 5 or 6 of them. Okay? And there is also one more problem on gravitation. So I'll include that in the list in this sheet. I'll upload it on Google Drive now. Okay, I'll upload it on Google Drive. Please solve these problems, and also the ones that we haven't solved in the class. The rest are easy. Okay, they will not take you too much time. The first few problems were time consuming. So please solve them, and send me the solutions on WhatsApp, whatever your approach is. Good. And on Monday we will go to the next math topic. But if you want me to send the solutions of these, of course I will, but I want you people to try these these questions on your own. So please send me your solutions on my WhatsApp number. I will go through them, and then I'll upload the solutions of these remaining problems. Okay? Fine, that's it for today. All the best.
What would be the proportion of these sort of questions in the exam?
Proportion, at least you can expect 2 questions like these. I haven't included the standard questions because we have already done that in our IISc course, right? The main purpose is just to take your understanding to a slightly higher level by solving more difficult problems, right? Matlab, see, what I mean to say is, it's not that all problems will be of this kind. Okay? It's not that all problems will be of this kind, but you need to be ready with that, because in IIT, very less number of questions are like this kind. As far as I remember, only that in this year, वो जो पानी में vertical circular motion था ना, वही mixed concept का था. But we can expect more of those in NEST. And traditionally it has been a more difficult exam than IIT. इसलिए मैंने ऐसे ही questions include किया. ठीक है? Okay. So all the best.
Sir, would you recommend us practicing a bit of advanced questions for NEST?
Yes. पहले तो नेस्ट के PYQs करो, मैंने ड्राइव पे डाला है. ओके, एंड देन इफ यू हैव टाइम यू कैन गो फॉर JEE एडवांस्ड. ठीक है? अच्छा, ऑल द बेस्ट फॉर योर IISc एग्जाम. लेट मी नो हाउ इट गोज.
So I have a small question regarding the IISc exam.
हाँ, you had sent me on WhatsApp. Is that the?
Yeah.
Let me read the brochure again, and then I think I can answer that question.
Okay, thank you.
Yeah. All right. All the best. And by chance, if you get the PDF of the IISc exam, or if you can check your responses, please let me know. We can also include those questions in our upcoming sessions. Okay? Bye. Our next session will be on Monday.
Okay.
7 a.m. Okay? Bye.